Hi, how you doing? This tutorial that I bring today deals with shrinkage strain effects and the problem of including these shrinkage strain effects in the load combinations according to Eurocode 2. So the novelty is that this is the first tutorial that I am doing using Robot Structural Analysis Professional. So let's start with the creation of a model. Now, for example, in Tools, in Job Preferences, I should check dimensions, for example, centimeters, properties in millimeters, with just one decimal position, and reinforcement areas in millimeters square, forces, I think it's okay, and other displacements, for example, in millimeters. I think that's okay. Now, in the case of the design codes for loads, I am going to use, instead of the Spanish structural code or the old Spanish standard for concrete, I'm going to use the European norm 1990. Yes, that's Eurocode 0. And that should be okay for the moment. So I'm going to create the structural axis for the moment resisting frame. In this case, okay, 3 columns, and in the vertical direction 2 stories. Here, for example, value, add, and apply, close. Now, for example, let's create the sections. Reinforced concrete column, (30 by 40), that's 30 centimeters, and 40 centimeters of depth. Okay, that's correct. Close. So this one, 30 by 40, here, and here, and here. Close. Now, this one can be copied. And now, for example, the beams. In the case of the beams, reinforced concrete beam, for example, 25 by 45. Yes, close. 25 by 45. So here, and close. The structure is here, and now I'm going to add the supports, fixed supports at the foundation points. So just here, 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 and here. Close. Now let's define the load types to be considered in this design. The first one is going to be dead load, which is of a structural subnature, and it is dead, and constant, because we suppose that the value of this permanent load is constant, and add. Then a second dead load is going to be the shrinkage, and in order to be able to combine it according to Eurocode, I am going to select the subnature non-structural. So shrinkage, and now the name. Another type, for example, 3, is going to be a live load of category C according to Eurocode 0, and this is occupancy 1. Occupancy 1. Add. the fourth, occupancy 2, a fifth load case, the wind, and finally the sixth case, the second wind hypothesis. So close. Now let's start with the deadlock. Here we can see that the bars have already a load defined, which is the self-weight and mass of these bars. I'm going to add a new load, which is, for example, vertical minus 25 kilonewtons per meter, and this one is going to be added here, 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 here. This is on the beams. And now the load is here with the value. The second one, for example, occupancy load, this one is just 15 kilonewton per meter, and here, here, and here, and the other case, occupancy 2, is the opposite case. So this one in these other beams. Close. Now the wind load, example, wind load of, in x direction, horizontal, value of 4, and add here and here. That's the windward columns, and the value for the leeward columns is 2, just half. And finally, wind load case 2, this one is the value of minus 2. This is in the leeward columns, and another value of minus 4 in the windward columns. Apply, close. Now the last load type is the shrinkage strains, which are defined here just with bar, introducing dilatation. In this case, the negative value will be shortening, so minus 0.0005, 5 times 10 to the minus 4th, and this one is going to be added in all the elements. Let's see the 8 columns and the 6 beams. Close. In order to see the value, we can just click here in job preferences, and in units and materials, the dimensions could be changed, the structure dimensions could be changed to scientific notation. And then here we see the value minus 5 times E minus 0.04. I'm going to switch again to dimensions, just conventional notation. Okay. Now, the problem here is that if we go here in combinations, automatic combinations, the combinations according to Eurocode 0, as we can see here, the non-structural depth should be factored by 1.35 with unfavorable effect. Nevertheless, in Eurocode 0, in Eurocode 2, in clause 2421, the partial safety factor for the shrinkage effects is to be defined in the national annex, and the recommended value is 1, which is different from 1.35. So here in the combinations, this should be changed by 1. The problem is that I do not want to change the Eurocode 0 regulations that are defined in robot structural by default. So here in robot structural, I cancel this operation, and I'm going to do the following. In the, let's see here in unit C, users, my name, in this case application data, roaming, Autodesk, an Autodesk Robot Structural Analysis Professional in configuration, I have this. I'm going to eliminate this value, and this is this RGL file. This one can be opened with, for example, the text editor, and as we can see here, this is the name, and here we have the non-structural safety factor of 1.35 that I'm going to change it to 0, 0. And this code is going to be called with shrinkage. And I'm going to save this file as all kind of files, and the name is going to be Eurocode with WSHR. Save. Now, hopefully, in the job preferences, in the loads, for example, design codes, loads, here I do not find yet this Eurocode 0 with shrinkage, but I can select more, and then by country, if I look for Europe, and here in Eurocode 1990 with shrinkage. I am going to add it to my default load combination codes. OK, and here I have the Eurocode 0 with shrinkage. OK, and here load combinations, automatic combinations, I have this Eurocode 2, this Eurocode 0 with number 1, and what is in practice 0 for favorable effect. That means this 0 would correspond to short-term effects with the shrinkage not yet developed, and the value of 1 for the shrinkage fully developed at long-term situation and with the factor of 1 according to Eurocode 2. The Eurocode 2, that's for concrete structures. So the next step here is to define the full automatic combinations. So I'm going to select only ultimate limited state combinations. Now the groups, for example, I have two groups, group 1 with the deadlock, second group with the shrinkage. Now, for example, in the case of the life, with an inclusive condition or for 3 and 4 occupancy loads, that means that we can have 3, 4 or both of them at the same time, and then an exclusive condition or for the wind. That means that we can have either wind 1 or wind 2, but not both at the same time. Now, what happens with relations? In the case of relations, I am going to add these two groups, which remember that the group 1 corresponds to dead load and the group 2 corresponds to shrinkage. So both of them are added here. Now, the live loads, which are cases 3 and 4 with the or inclusive, are going to be added by clicking here. And finally, the wind is going to be added by clicking here. So we have dead loads, G1 and G2. G2 is non-structural, live, Q1, and wind 1. And I click generate. Now, in order for the combinations to be created, I must calculate the structure. And now, hopefully, we could be able to see here the combination table. And in this combination table, we have 72 combinations. We can check this combination table and we can see that, for example, in some combinations, the shrinkage has been taken into account, and in other combinations, it doesn't have been taken into account. For example, 14 has the dead load factor by 1.35, and the combination 4 has this one and also the shrinkage by 1. If we calculate now the bending moments, and these are 72 combinations, this is 36 combinations without the shrinkage, and another 36 with the shrinkage effects. Now, for example, the results, the bending moment, and field, text, and apply. And here we could be able to see, for ultimate limited state combinations, the envelopes for the design bending moments of this structure. I hope that this tutorial has been interesting for you.